So we're Team Random Word Generator, and this is our final report. So for questions, we first pre-process the articles by splitting them into lines, and then splitting sentences with NLTK, and then tokenizing the lines. And for the first sentence of the article, if we can find pronunciations between two slashes, and if the first letter matches the first letter of the word before it, we can ask pronunciation questions. So if a sentence has is or was as its copula, we can use dependency parse to find the subject and the object. And then we can ask questions like is subject object, WH is subject, and if there's a prepositional phrase in the object, we can move that to the beginning of the sentence. So we have pretty high confidence in the is subject object questions. So we can ask questions like is subject not object. We can replace numbers and ordinals like first to second, most to least, and also replace words with hypernyms like city to municipality. Also, we can generate questions with constituency patterns, like if there's a because of phrase at the end, we can ask why questions. If there's a by phrase at the end, we can ask how questions. Also, if a sentence starts with a pronoun, we can replace it with who or what, and this is pretty simple, but generated pretty good questions. Also, for lines with multiple sentences, we can run co-reference resolution and take the animate entities, and for each entity, we can find the related clauses. So this is an example. Here you can see the information. And for one entity, we can find clauses and ask, was the person who clause 1 also the one who clause 2? We can replace also with not. And then for two entities, we can mix and match their clauses.
For the next set of questions, we use named entity recognition using Spacey. So for this first type, we basically, in each sentence, we identify all the entities using named entity recognition, and then replace that entity with either a when, who, or where. So then, for instance, if the entity is a person, we just replace it with where, with who, and so forth. The other type of question we can do is is blank or blank this statement. So for this, instead of tokenizing the sentence, the line into sentences, we use that entire line first, and then we find all the objects in that line and the NER label, and then group those objects by that label. So then for each sentence to make the question, we just find the object in that sentence, and then if that object is a recognized entity, we find entities that are similar, that have the same label as it, and then add to the end of that object a or blank, and then question mark. And then for the last type of question, we use prepositions to further make other questions with who, what, or when. So then in each sentence, we find the preposition and then check if the word following the preposition is the complement of the preposition. This just helps to make the question flow a little better. And then we find the phrase that corresponds specifically to that preposition using a dependency tree. And then we check in that phrase if the phrase is like either the type, it's NER label, and then we replace that phrase with who, what, or when as well.
So for question filtering, we remove questions by length, and then we remove questions with pronouns as well. And then for question ranking, our assumption is that diverse questions are better questions. So we first shuffle all the questions, and then for all the questions, we get a set of unique question types and also questions from different lines. And then we take the top n questions.
The answering subsystem can be further divided into two parts, the matching part and the answering part. The three main techniques used are TF-IDF in sklearn, Spacey, and Stanford Core NLP. The first is to find the most matching sentence of the question in the text entry. The rest two are for NER and co-reference recognition. They are for the answering part. The idea of looking for the most similar sentence was very straightforward, but using what tool was not very clear at first. Doc2Vec is probably more robust and powerful to get the information of the sentences. However, there are not enough data to train the representations format is a bit different and the matching is not that complex. So actually we don't need to use Doc2Vec. The method of TF-IDF, though simpler, can satisfy the needs of our system pretty well. For each sentence, the tool returns a vector of keywords weights, like the long word here. After calculating the cosine distance of two sentences and comparing, we can get the best candidate and two score vectors. To answer yes or no questions, we simply compare the two vectors mentioned above. If matching words weigh more than 80%, the answer is yes. This means if there are some important words missing, the question is making a false statement. We also have one wrong word buffer for robustness, like Nicola here. Some special cases are judged, like numbers of negative words and Arabic numerals. To answer WH questions, spaCy is used to get corresponding words or phrases. For example, date and time for when questions and location for where questions, like the phrase here. Given one WH word, the system can have a set of non-entities in the best matching sentence. At last, we return the missing one. There's an exception. When generating who questions, sometimes the pronoun like he or she is replaced, like the example here. In this situation, spaCy solution doesn't work, so we use the tool to extract coreference information. We can get representative mentions of nouns given several sentences. We use the paragraph which the candidate is in to run coreference annotator. And thank you.